distance formula and section formula in 3D geometry. In our previous classes, we have studied how to define a point on a piece of paper. Somebody is asking you what is the position of this point on the blackboard or on the piece of paper. Suppose I'm putting A here on the piece of paper. I need at least how many coordinates to express this exact position here? I need 2 coordinates. So 2 coordinates are necessary in this piece of paper to get the exact position. So that is nothing but 2D geometry. Now, instead of this paper, if I'm taking a fish tank, I have a fish tank here and there is an object. It can be either a fish or some small stone. So I'm putting that position of that fish as C. How many coordinates do I need to express the position of this point C or the fish inside that tank? Will 2 coordinates be enough to express the position? No, because this point C, suppose from the left I'm saying, this is 1 meter from the left and 2 meter from the bottom. Can I get the exact position of the fish? No. 1 meter from the left and 2 meter from the bottom will only give us the 2D position of that particular object. To get the exact position of that object inside the tank, I need one more coordinate, and that coordinate will be from either the front side of the tank or the back side of the fish tank. You can just try it out if you have a fish tank in your home. So that gives us one more coordinate to express the exact position. So that means 3 coordinates are needed to express the position here in this fish tank. And what is the difference between that piece of paper and this fish tank here? From 2D, we are now coming on to what? The 3-dimensional one. So a 3D geometry is being introduced here, and the distance formulas, section formulas that we have studied in 2D has to be changed here. So let's look at what is the distance formula. Suppose there are 2 points inside the fish tank, A and B. To express a point in 3D geometry, we need how many coordinates? 3 coordinates. Same as we define points in which one? A paper or a 2D figure, we have only X and Y coordinate. We need an extra coordinate, that is which one? The Z coordinate. So this point A, I'm putting here as what? X1, Y1, Z1. And the point B, I'm putting it as X2, Y2 and Z2. So this is now in 3D. So the distance between these 2 points, A and B, AB, is nothing but the same as that we have studied in 2D. In 2D, what is the formula? It is root of x2 minus x1 the whole square plus y2 minus y1 the whole square. Now in 3D, since there is an extra coordinate, the distance between the 2 points, that is a distance formula, is nothing but root of x2 minus x1 the whole square plus y2 minus y1 the whole square plus z2 minus z1 the whole square. So this gives us the distance between the points A and B in what? 3-dimensional geometry. I hope you have understood what is the distance formula in 3D. Moving on to the next one, that is the section formula. Suppose you have 2 points and there is another point which divides the line joining these 2 points, and you need to find out the ratio. So to find out the ratio, we need to use what? The section formula. And in 2D, what we have studied, suppose you have 2 points A and B, that is x1, y1 and x2, y2, and they are divided by the ratio m:n. There are 2 ways you can divide it. You can divide it internally and externally. If it is internally, we have studied the coordinates of the point which divides them in the ratio m:n will be mx2 plus nx1 by m plus n, comma, my2 plus ny1 by m plus n. So this is in internal division in section formula. And externally, what will be the difference? There will be a change in the sign, that is mx2 minus nx1. So externally, it will be mx2 minus nx1 by m minus n and my2 minus ny1 by m minus n. So this will be in external division. This is in 2D. In 3D geometry, what is the difference? There is an extra coordinate. So what happens? You need to just put that extra coordinate there. So in 3D, when you are dividing 2 points, that is x1, y1, z1 and x2, y2, z2 in the ratio m:n. So here the points A and B are now divided in the ratio m:n in 3D. That is, first I'm dividing it internally. So if it is an internal division, the coordinates will be mx2 plus nx1 by m plus n, comma, my2 plus ny1 by m plus n, comma, mz2 plus nz1 by m plus n. So this will be the coordinates of the point in internal division. Externally, what will happen? The signs will change. That is mx2 minus nx1 by m minus n, my2 minus ny1 by m minus n, mz2 minus nz1 by m minus n. So this is the section formula in 3D geometry. So when you are asked to find out the coordinates of the point where they are divided in the ratio m:n internally or externally, you need to use directly this formula to get the answer. Now this section formula, I can use that to find the midpoint also. Suppose you have 2 points A and B. So to find the midpoint of A and B in 3D geometry, suppose I have A as x1, y1, z1 and B as x2, y2, z2. What is the midpoint C of AB? So there again you can use section formula, but directly, since it is a midpoint, it will be in the same ratio. The two parts will be in the same ratio, or 1:1. So in that case, you can directly write the midpoint C is nothing but x1 plus x2 by 2, comma, y1 plus y2 by 2, comma, z1 plus z2 by 2. So this gives us what? The midpoint of the line AB in what? 3D geometry. Now again, if I have a triangle here in 3D and I need to find the centroid of the triangle, ABC in what? 3D geometry. So A, B and C. A is x1, y1, z1. This is x2, y2, z2. And this is x3, y3, z. The centroid of the triangle ABC here can be found. That is, suppose if I'm putting it as G, centroid G can be found out using the formula x1 plus x2 plus x3 by 3, comma, y1 plus y2 plus y3 by 3, comma, z1 plus z2 plus z3 by 3. So this gives us what? The centroid of triangle ABC. So that is about different formulas that we use. That is, first one is distance formula that we studied. Then we studied section formula. And now we have studied the midpoint and the centroid of a triangle ABC in what? 3D geometry. Suppose you are asked a question to find the distance. Suppose you are asked, find the distance between the points (2, 4, -1) and 3, 2, -3. So if they're asking you to find out what is the distance between these 2 points. So AB, if I'm putting, that is, what is the formula in 3D? x2 minus x1 the whole square plus y2 minus y1 the whole square plus z2 minus z1 the whole square. Now here it will be directly 3 minus 2 the whole square. You can just directly substitute 3 minus 2 the whole square plus 2 minus 4 the whole square plus minus 3 minus minus 1, it is minus 3 plus 1 the whole square. So that gives us 1 square plus minus 2 square plus minus 2 square, or it is root 1 plus 4 plus 4. So root 9, that is equal to 3 units. So you get the distance between what? The points 2, 4, -1 and 3 to -3. And using the same distance formula, some questions can come in with which way? To find whether the given coordinates form a right angle triangle. Suppose there are 3 coordinates, A, that is 2, 4, 3, B, 3, 2, -1, and C, 6, 5, 0. So these are 3 coordinates, and they're asking us to check whether these 3 points can form what? A right angle triangle. So check whether these points form a right angle triangle. So same way we are finding out AB. So AB is nothing but 3 minus 2, 1 square, plus 2 minus 4, minus 2 square, plus minus 1 minus 3, that is minus 4 the whole square, and that is equal to 1 plus 4 plus 16, that is root 21. So that is AB. BC is equal to same way 6 minus 3, 3 square, plus 5 minus 2, 3 square, plus 0 minus minus 1, 1 square. So that is root 9 plus 9 plus 1, that is root of 19. So that is BC. And the same way, what is AC? The third side, 2 minus 6, that is 4 square, plus 4 minus 5, minus 1 the whole square. 2 minus 6 is minus 4 square plus minus 1 square plus 3 square. So that is 16 plus 1 plus 9, that gives us root 26. So AB, BC and AC we got. So if we have AB, BC and AC, what is the square of AB? AB square is 21, BC square is 19, root of 19 square is 19, and AC square is 26. So if I take any two sides, the square of any two sides and add them, am I going to get the third side square? Let's check. 21 plus 19, it's not going to give me 26. 21 plus 26 is not going to give me 19. So 19 plus 26 also is not going to give us 21. So the Pythagoras theorem that we have studied is not at all satisfied. So since it is not satisfied, then what we can say about the 3 points A, B and C, will they form a right angle triangle? No. So here, they won't form a right triangle. They will not form a right angled triangle. Now suppose if 2 points are given and there is a ratio also given, and they're asking me to find out what is the coordinates which divides them in the ratio. Suppose A 3, 0, minus 2 and B minus 2, 1 and 7. So these are the 2 points and they are divided in the ratio. 2:1. So they are divided in the ratio 2:1. Now I need to find out which point will divide them in the ratio 2:1. So using the section formula that we have studied, that is 3, 0, negative 2 and minus 2, 1, 7, and the ratio here is 2:1. So AB, the line AB, if it is divided by the point C, what are the coordinates of C? Since it is an internal division, you can find C using the formula mx2 plus nx1 by m plus n, my2 plus ny1 by m plus n, mz2 plus nz1 by m plus n. So directly if I put all this, I'll be getting 2 into negative 2 minus 4 plus 1 into 3, 3 by 2 plus 1, 3, comma 2 into 1, that is 2 plus 1 into 0, 0 by 2 plus 1, 3, 2 into 7, 14 plus 1 into minus 2, minus 2 by 3. So that gives C is equal to minus 4 plus 3 by 3, that is minus 1 by 3, 2 plus 0 by 3 is 2 by 3, 14 minus 2 by 3 is 12 by 3, or that is nothing but 4. So you get the coordinates of what? The point which divides the line AB in the ratio how much? 2:1. So directly we have substituted section formula here to get the answer. So I hope this session we have studied almost all parts of the distance and section formula in 3D geometry, and also we have covered what is a midpoint formula there, and also what is a centroid of a triangle. And using the distance formula, we also did a question to check whether the points given are forming a right angle triangle or not. So I hope this session was very useful to all of you. Hope to see you in the next session. Until then, keep exploring.
Manorama Horizon. Learning made simple.